In-memory tests are fast, and you should have a lot of them. But some bugs simply don't exist in memory. Two users editing the same record at the same instant. A migration that's wrong. The transactional outbox that has to commit your data and your event together, or not at all. None of that shows up against a fake. So this is the tier where we test data for real, against an actual database engine, and accept that it's slower in exchange for catching the bugs that only live there. Let's flip the switch. What does a real database catch that in-memory can't? Three big things. First, concurrency. Two writers racing on the same row. Only a real engine with real row versioning will reject the stale right the way production does. Second, migrations and provider-specific SQL. Your schema and your queries behave like the database you actually ship on, not like a convenient stand-in. And third, the outbox. The pattern where a domain change and the integration event it emits have to be committed in a single transaction, then delivered exactly once. That atomicity and that exactly once delivery are real database properties. To test any of these honestly, you need the real thing. There are two ways to get a real database into a test, and they share the exact same seam. Path 1, the environment flag from episode 1. With useReal services set, the fixture stops swapping in the in-memory database and just returns. So the very same WebApplicationFactory tests now run against the app's real provider. Same tests, real engine. Path 2, for full production fidelity. You spin up a throwaway database in a Docker container with Testcontainers, a third-party library, not part of Trellis. A couple of lines start a real Postgres, and you point the app's DB context at it. When the test ends, the container is thrown away. Either path, the tests don't change, only what's underneath them does. Here's a concrete bug that an in-memory test can miss and a real database catches: an optimistic-concurrency conflict. We create a to-do and get its version, its ETag. Then imagine another writer updates it first, so the row's version moves on. Now we try to update using the old, stale version in an if-match header. Against a real engine with real row versioning, the database sees the mismatch and the write is refused with a 412 precondition failed. This is the test that proves two users can't silently overwrite each other. And it only means something when the row versioning is real, which is exactly why it belongs at this tier. Let's run it for real. This is the same API test project from episode 8, but now with useReal services set to true, so every one of these tests is hitting an actual database, not an in-memory stand-in. Same 74 tests, same green result, but this time they've exercised real SQL, real migrations, and real transactions end-to-end. It's slower than the in-memory run, and that's the whole point. This is the tier you run deliberately, not on every keystroke. The deeper, realer check underneath your fast base. Last, the outbox. The reason this episode pairs data and events. Trellis ships a transactional outbox. You switch it on with add Trellis unit of work, and it guarantees that when a command changes an aggregate and raises an integration event, both are committed in a single transaction, never one without the other. Against a real database, you test two properties: atomicity, that the event row lands exactly when the data does, and idempotent replay, that if the dispatcher redelivers, which it will, eventually, the event is published once, not twice. And because all of this is slow, you mark these tests category integration. On your machine, everything runs. On the build server, the fast core runs, and these are filtered out. Run for real when it matters, on a schedule or before a release. So that's testing data for real. Flip a flag to run your existing tests against the actual provider, or spin up a real Postgres with test containers for full fidelity, and use that tier to catch what in-memory never will: concurrency conflicts, migrations, and an outbox that's atomic and exactly once. Mark them integration, run them deliberately, and trust your data layer the way you trust your domain. Next time, we cross a boundary between services and pin the contract between them, so one team's change can't silently break another's. Subscribe, and I'll see you there.